You can have data without information, but you cannot have information without data. This is a famous quote by Daniel Keys Moran. A very good morning to everyone. It is my immense pleasure to welcome all of you with this beautiful morning with new challenges and opportunities. Data analytics is the science of analyzing raw data. The Department of Computer Science and Applications of St. Mary's College, Thrissur proudly presents the international webinar on the topic Data Analytics and Applications, presented by Ms. Anne Mira Joseph, software developer, magnetic forensics from Canada. Starting the day with a prayer is always a good omen. Let's start our program by seeking the blessings of Almighty with a silent prayer. Thank you. Thank you. Now I request Jubit Pensi of second year BCA for the welcome speech.
Good morning, dear guests and participants. We're so glad to have you all here for this session. We appreciate your presence at this difficult time. Today, I've been given the privilege to welcome each and every one of you to this international webinar titled Data Analytics and Applications, organized by the Department of Computer Science and Applications, St. Mary's College, Thrissur. First of all, I'd like to welcome our principal, our support system, and the backbone of our college, Dr. Sister Maggie Jose. Welcome, dear sister. Next, I'd like to welcome our resource person of the day, Ms. Anne-Mira Joseph, who is a software developer at Magnet Forensics in Waterloo, Canada. She will be enlightening us on data analytics and its applications further in the session. I welcome you, ma'am. Next, I'd like to welcome our HOD, Mrs. Betsy Chaco, and all the teachers who have been working for this webinar. Welcome, dear teachers. Last but not the least, I'd like to welcome all our dear participants to this event. I welcome each and every one of you, and I hope you all have an informative session ahead.
Thank you, Jubit. Next, I welcome our dear principal, Dr. Sister Maggie Jose, to address the gathering.
Respected dignitaries of this webinar, especially the resource person, Anamra Joseph, a warm good morning to all. Today's topic of discussion is data analytics and its applications. Data analytics is a science of analyzing data in order to make conclusions about that information. Many of the techniques and process of data analytics have been automated into mechanical processes and algorithms that work over raw data for time consumption. Skilled data analysts are some of the most sought after professionals in this world because the demand is so strong. Its applications are very wide in nature. Some organizations are using its applications in security, transportation, risk detection, etc. In this webinar, we can learn more about this data analytics and its applications in various fields. Today's resource person, Dr. Anne-Mira Joseph, is a software developer in Canada, is a very apt person for handling this topic. Once again, I welcome you, ma'am, on behalf of myself to this webinar. I take this opportunity to congratulate the staff members and students of the Department of Computer Science, especially HOD Betsy ma'am and Coordinator Rashmi ma'am for organizing such a useful webinar. Hope all the participants will make use of this webinar. Wishing you all a blessed and fruitful day ahead. Let me stop. Thank you.
Thank you, sister. Just giving some instructions before we start our session. If you have any queries, please wait till the end. We'll have a question and answer session. To keep the quality of sound functional during the meeting, please mute yourself when you are not sharing and do remember to unmute when you wish to share. Please ensure that you do not share your screen without any prior information. Now, without any further ado, I welcome our resource person, Ms. Anne Joseph. She works at Magnet Forensics as a software developer. She did her Masters of Data Analytics at Western University in London and BE in Computer Science Engineering from MS Ramya Institute of Technology in Bangalore. I hope we all will have a wonderful session. Over to you, ma'am.
Thank you so much, everyone. Can you hear me okay? Everything's okay? Okay. My name is Anne Joseph, and thank you so much for welcoming me and letting me be a part of this. I am super excited to talk to all of you guys about data analytics. So yeah, without further ado, let's do it. And you guys already kind of touched base about what data analytics is, but basically, as you said, it's the science of analyzing raw data in order to make conclusions about some sort of information. And so it's a combination of computer science, mathematics, and statistics. At the core of it, it's basically statistical modeling, and those statistical modeling, that logic you put into, you actually use it using computer science and programming and all that stuff. And it helps businesses make better decisions. It helps them optimize their performance. It helps them analyze customer trends to see what to do next and how to profit. And even though that is like a little bit of a funny comic, that is really what data analytics does. It's used in healthcare, and we're able to predict if a person is at a higher risk of having cancer or heart failure or disease, and how to prevent that. So there are a couple of types of data analytics. There's 4 different types. The first one is descriptive, which is just what has happened over a given period of time. So have the number of views on your website gone up, or are sales stronger this month than last month? The second type is diagnostic analytics, which focuses more on why something happened. So why did your sales go up? Did the weather affect ice cream sales? Did your latest marketing campaign impact sales? All of that's diagnostic. And then you have predictive analytics, which is what is likely to happen in the next term, given everything that has already happened. So if you know that sales were great last summer, can you predict what sales would be like this summer? And then lastly, you have prescriptive analytics, which suggests a course of action. So in the case of healthcare, if you know that a certain person is at a higher risk of having a certain type of cancer, then what can we do to prevent that from happening? What are the factors that we can change so that doesn't happen? So those are the 4 types of data analytics. And now I'm going to talk a little bit about the analytics process. So you have 5 steps. Your first one is determining your data requirements. And that just means talking or figuring out what you're trying to do with your analysis, what is the end goal, and then figuring out how to get your data so that you reach that end goal. Your second step is data collection. So now that you need all this data, where are you getting it from? Are you getting it from multiple sources? Does this data already exist? Do you have to generate this data? Do you have the permission to access this data? Do you have to ask someone to get that permission? All of that, retrieving from multiple sources and getting it all together is data collection. And then you have data pre-processing. So sometimes when you have data, you have certain parts that are irrelevant to what you're trying to do. And so you want to remove those, or if you have blank or null values, your data's not complete, it's a little noisy, you want to fix all of that. You want to standardize and normalize before you go on. And so all of that together is data pre-processing. And then you have exploratory data analysis, which is just building graphs and looking at your data. Just initially, what can your data tell you about what's going on? So plotting bar graphs, scatter plots, and all of that, trying to find relationships within the data, and then going from there. And then finally, you have model building. So as someone said, there are very many algorithms, machine learning algorithms that you can use to build your models. And basically model building is just a way of telling, so a model is like just a system, and the system is able to understand these relationships within your data. And then using that, it's able to tell you something useful. It's able to predict something for you. So those are the 5 steps. And I thought a good way of explaining how to do this would be to really, really break it down. And so what you'll see is that the way we train our data analytics models to do things is very similar to the way we learn things. And in order to put that point across, I have this one example. So the question here is, how would you teach a baby the difference between a cat and a dog? We all know the difference between a cat and a dog, but if someone was to ask us specifically, like, what are the features that a dog has that a cat doesn't have, and you're able to tell the difference, we wouldn't really know. But we're going to do it anyway. So how would you teach a baby the difference between a cat and a dog? So the first step, as we said, is determining your data requirements. So what we're trying to do is teach this baby the difference between a cat and a dog. In order to do that, we have to show the baby pictures of cats and dogs. And so our data requirement here is gathering as many pictures of cats and dogs as possible. And then you have your second step, which is data collection. So maybe you don't have pictures of cats and dogs just lying around. So maybe you have to go outside and actually take pictures of cats and dogs and get that data. Maybe you have friends or family on Facebook or Instagram that have uploaded pictures of cats and dogs. So you need to talk to them and say, hey, can I have access to your data? You need to make sure you have permission, and then you can get your data that way. Maybe you just Google it. You just say cats or dogs on Google, and you get a bunch of pictures, and that's how you get it. And then maybe you do a combination of any of these things. So this is all your data collection, where you're either generating data, you're getting it from somewhere, but you're making sure that you have the permission for it, or you're getting it just online somewhere where everything's fine. Next, we have data pre-processing or cleaning. So assuming these were some of the pictures that you got from your various sources, and let's say some of the pictures were really, really big and some were really, really tiny. So you have to standardize or normalize them. So you want to make all of them the same size so that your baby isn't confused. And then also maybe your friends sent you a picture of a man dressed up like a cat or a dog, and you don't want to show your baby that would confuse your baby. So you want to remove that. Or maybe you asked for a picture of a cat and a dog and someone sent you a picture of squirrels, and you don't want that either. So you want to remove all that noisy, unclean data so that you have your clean data to show your baby, so that your baby understands the difference. And then we have our actual modeling. So once we've actually figured out, or once we've retrieved our sources, we've cleaned it, we have our good, clean set of pictures of cats and dogs, we will literally go to the baby and say, this is a dog, this is a cat, this is a dog, this is a cat. These are dogs, these are cats. And we keep doing this over and over and over until finally the baby is able to tell the difference between a cat and a dog. And that's how we probably learned to tell the difference between a cat and a dog too. And how the baby does this maybe is because the baby notices certain features in a cat that a dog doesn't have. Maybe a cat has longer whiskers, maybe a dog has a longer tongue. And so the next time you show a baby a picture of a dog, it's able to say, yes, this is a dog because it has these and these features that only a dog would have. So that's kind of how modeling works too. And what we're going to do now is go through a case study. So I chose this one specifically because the Titanic is pretty well known. I had assumed that everyone, at least most people here, would have seen the movie. So anyway, so we're going to do survival analysis, in Titanic dataset. This is part of a project that I did a couple of years ago when I was in university. It's a good way to start, and I think there's lots of resources about this specific project or case study online. So it's a good way, if you know nothing about data analytics, it's a good way to get into it. So anyway, what we want to do here is, given a passenger's details, so given their age, their gender, their whether or not they were in first class, second class, third class, given a bunch of details about a passenger, we want to be able to say whether or not they survived the Titanic. So of course, the Titanic, I think it went from Southampton to New York City. There were 2,200-ish passengers on it, and about 1,500 died. And so we want to be able to say, okay, if this new person was on the Titanic, would they have survived or not? And so our data requirements for this are the details of all the passengers that were on the Titanic. And so what we would do is literally, as we did with the baby, we would say, these are the details of this passenger survived. These are the details of this passenger did not survive. And we would keep doing that. And then magically we would have a model. So then data collection, this data set is on Kaggle. Kaggle is a great resource for anything data analytics related. So again, if you wanted to start, but you didn't really know where to start, Kaggle is a great website. There's lots of online, just free data sets, lots of really cool ones. There's competitions that you could get into and prizes you could win. There are ways to collaborate with other people all over the world. So Kaggle's a good place to start if you did want to do any of this. But yeah, that's where I got my data set from for this case study. And this is what our data looks like. So there's about almost 900 rows. There are 12 columns. There's the passenger ID. There is whether or not this passenger survived. There's the class that they belong to. So whether they were first class, second class, or third class. Their name, their sex, their age, if they had a sibling or spouse on board, or the number, I think, of siblings or spouse on board, the number of parent or children on board, their ticket number, how much fare they paid, their cabin name number, I want to say, and then where they embarked from. So I think there were 2 ports. There was S and C, and so where they embarked from. So those rows there that you see are the details of each passenger. And as we said, the third step is data pre-processing or data cleaning. So we would remove first any columns we didn't think were relevant to what we were doing. And in this case, there's passenger ID, there's name, there's ticket number. And none of those things really make sense to what we're doing. Like whether or not a person is named Peter or John has no relevance to whether or not they survived. Their name would make no difference at all. Similarly for passenger ID and ticket number. So we would just remove those columns. We don't want an excess number of columns. We don't want to overwhelm our model. So we would just remove the ones that we think are unnecessary. And then next, similarly for the fare column and the cabin column, we would remove those because that information is already captured in another class column. So if you're in first class, you would always pay a specific fare and you would always be in a set number of cabins. And similarly for the other classes. So there's no need to have these two extra columns, whereas your class column already captures that information. And then you have to remove or deal with null or blank values. You don't want noisy data. You don't want incomplete data. You want all of your values to be there. And then the last thing that you would do is in the previous slide, you saw how survived, that column had 1 or 0 values. You would just change that to yes or no, or survive, did not survive, something like that. So you would change your 1s and 0s to actual categorical values. And then you have, this is where the fun starts, you have data visualization or exploratory data analysis. And this is where, like I said, you're just plotting your data just to see if, like, at a first glance, is your data telling you something? Can you understand relationships between different predictors or columns? Are there any outliers that you need to remove, or any outliers that are just like suspicious? Any outliers that make you go, that doesn't look right. So that's the next step. And I've plotted some graphs for you. So this first one is the survival rate in men and women. I want a highlighter. Okay. It's a survival rate in men and women, where right here, that's not what I want, okay. Where right here, this graph is female, this graph is male, you have your age on the x-axis and the number of people that survived or didn't on the y-axis, and blue is survived, orange is not survived. Just at a first glance, what you can see is there's definitely more women that survive than men. Like, this is very, very blue. This is very, very orange. And that makes sense. I don't know if you remember in the movie Titanic, they say women and children first, women and children first, when they're trying to board onto those smaller boats. They say women and children first, like that's who they're trying to save first. And that's what we can see in this graph. There's lots of blue here. And also the blue here, the number of people that survived right here are the same, regardless of male or female. And those are children. Those are children about 8 years or younger, which again makes sense. They said women or children first. And then, yeah, so like that, there are some cool things that you could see from this graph. And I think, yeah. And then I did another one where I did survival based on class. So, whether or not they were first class, second class, or third class, how many people survived. And it's very obvious here. And I think it makes sense also that they would go to first class first and say, please go get on the boats before they went to the other classes. And that looks like that's what's happening, where the number of people that survived in first class is so much greater than that in third class. And I decided to break that down a little further. So this is, again, survival based on class, where you have this column. All of this right here is not survived, so survived equals 0. And all of this is survived equals 1. What you can, and then, also, I guess, this row here is first class, this row is second class, and this row is third class. And what you can see, and what's very glaringly obvious, is in third class, the people, like almost all of them didn't survive. And then in first class, again, there's most people did. And then in second class, it's a little bit of both, sorry. So yeah, so Oh, and then I have another one. Okay. And then this other graph is survived based on relatives on board. So I don't know if you remember, but when I was showing you the data, there was columns for parent and children and for sibling or a spouse. And so I put those together and called that relatives. And so based on the number of relatives on board, was there some sort of relationship that I could figure out? And it looked pretty interesting. And it also kind of makes sense that if you have a lot of relatives on board, you're so busy trying to save them and take care of them that it just might not work out. And that's why survival is a little low. Whereas if you have less number of relatives, it looks like your survival rate is higher. So like that, data can tell you, just on initial glance, there's a lot that data can tell you. There's a lot that you can, there are stories that you can make of it. There are things that you could try to figure out just by looking at it like in graphs. So anyway, so what do we learn so far? We learned that gender is probably a factor. We saw that women had a higher survival rate than men. Age is kind of a factor. We saw that in both cases, both genders, children survived no matter what. We saw that class is probably a factor. We saw that if you were in third class, you probably didn't survive. But if you were in first class, you had a really good chance of surviving the Titanic. And then we saw that maybe the number of relatives on board is a factor. We saw that if you have a lot of relatives on board, that might not be great for you. You might not survive. And then now that we know those relationships and we know that there's definitely some factors in there that we could use to help us predict whether or not another new person survived. Now we do some modeling. So I won't go into the details of any of the models. I'm trying to keep it very high level and just like a brief kind of overview. But there are many different models or modeling algorithms that you could use to build your models. There's linear logistic regression, decision trees, just all that stuff. Usually, like programming language wise, I've personally only used Python and R. I really like Python for visualizing my data. It has a lot of inbuilt methods where you just put in your data and it shows you a nice, pretty graph. And I've used R for actually building my models. I found that, at least whenever I've tried, I found that R is a lot more powerful than Python in that way. So yeah, I thought we would kind of talk about decision trees. It is a modeling algorithm. It's pretty easy to understand. So basically, a decision tree is just visually representing every decision that a model takes. And so what we would do is we would show our model the first passenger, and our model would say, and our model would know that this passenger did not survive, but we would show the details to the model and say, this is the passenger details, he did not survive. And then our model would try to figure out like relationships between factors. So is this passenger male? Yes. Is this passenger less than 3 years old? Yes. Is this passenger, is this passenger in first class? No. And so, that passenger didn't survive. And our model would keep doing this with multiple passengers. It would keep reading in details and then being like, okay, that passenger didn't survive. That passenger did. That passenger didn't. That passenger did. So it would keep doing that. And then finally, it would collaborate all of that, and it would give you like a probability of if a passenger is male and they were above 40 and they belong to second class, a probability of them surviving versus them having died. And so then that's what you can use to predict for the future. So if you have a new passenger and you want to figure out if they survived or not, you would, again, once you've built this model, give it details, and the model would be able to tell you with a probability whether or not that passenger survived. So that's some of the cool things that you can do with data analytics. But then also, like, why do you care, right? Like, data analytics is cool. It's a buzzword at this point. Everyone's talking about data analytics and machine learning and AI. Data is always being generated. You hear about all of this, but like, okay, so what? Well, the thing is, data analytics is everywhere and you're using it every day, whether you like it or not. We're transforming politics with it. It is the most valuable resource in the oil and gas industry. It's, in healthcare, it's improving patient care. We're able to predict whether or not a person has a high risk of cancer or some sort of failure or a disease. It's used actively in sports. It's used in sports all the time. The government uses it for a lot of public programs. The police use it to prevent crimes. I work in a digital forensic software company, and we use it to help police officers in their day-to-day life. And so it's used everywhere, all the time. It's you use it without knowing it. You use it every day. And the reason that it's used so widely is because we're in a day and age of big data. And we've never seen data like this. Like, there is data being generated all the time. Just you in 1 second of 2020 is generating 1.75 MB of data. There's more than, in every minute of this year, 2020, there's more than 41 million messages being sent on WhatsApp. There's 6,600 packages being shipped on Amazon. TikTok is installed 2,700 times every minute of the day. Facebook users share 150,000 messages. Customers spend $1 million online. And this is every minute of the day. So you can imagine how much data is generated just by going online for a second or going on your phone for a second. If you wear a smartwatch or something, just walking somewhere, sitting, everything generates data. And all of these, apps, all of these websites, they're using your data to make sure you stay on their website. So I remember one of my friends said that she would go on YouTube for a 5-minute video, and then she would spend like 2 hours on YouTube. And that's because you go on YouTube, you watch this video, and then there's a suggestion, and then there's another suggestion. And YouTube's really great at giving suggestions, and that's because YouTube knows what you've watched in the past. YouTube knows what people like you have watched in the past and what they're interested in. And they know, because of all of that, they know how to keep you on YouTube. And Facebook shows you posts of random things that you didn't know, but that you're interested in, because Facebook, again, knows you. Facebook knows what you spend time on, what you're reading, what you're liking, what your friends are liking, what people like you are liking. And so like that, data is everywhere. Data is being generated all the time. And that's why big data is such a thing now, that data analytics and AI is such a thing now, because just from this tiny little Titanic data set, we were able to draw conclusions and find relationships. So then imagine if you had all of this information, what would you be able to find? conclusions, what relationships would you be able to draw? It's kind of mind-blowing. But some common applications that you definitely have used other than YouTube and Facebook. Google Maps is able to tell you how much time it'll take to get from point A to point B, and also what the best route is. And it does that by looking at previous data, previous weather data, previous traffic data. It also has user-reported traffic information, but there's a lot of old data that it analyzes to give you that fastest route, to give you that estimated time. Commercial flights use autopilot, and so like lots of times when you're on a plane, I've been told that actual pilots only fly the plane about 7 minutes in the beginning and 7 minutes at the end for taking off and landing. But otherwise, it's all autopilot, and all of that's data analytics and AI technology. Email intelligence. So if you get an email and that email directly goes to your spam, directly goes to one of your email folders, that's because of data analytics. Smart replies. I know Gmail's done this, where you're typing out a message and you just type out one word and it kind of fills in the entire message for you. Smart replies, data analytics. Social networking, facial filters, where it'll put an old face on you, it'll put different hair on you or dog ears on you. All of that's data analytics. Automatically tagging on Facebook. So if I were to upload a picture of my sister, Facebook would say, hey, is this your sister? Do you want to tag her? Because they're able to detect faces and understand who's who. Again, Facebook only shows you the content you're interested in so that you stay on Facebook longer. All of that's data analytics. Another thing that I learned very recently that I thought was very cool is if you and I were to go on Google and type in the same word. So if I were to say, or just type in the same letters. So if I were to say the S, and you said the same thing, the suggestions that I would get to fill in my search would be incredibly different from the suggestions you get. And that's because Google knows my history, and that's going to be different than yours. Google knows the people around me and what they're talking about and what they've searched. And Google knows that I am in contact with those people. So if I have ever had conversations with those people, it would be about these things. Google knows that in Canada right now, there are certain things that are popular. There are certain things that I would hear about and that I would possibly search. And that would be different from the things that are in India and the things that are popular there and the things that people there would search about. And so there's so many ways that data analytics and AI are being used for us, with us, against us. It's being used, and we all use it on a day-to-day, and it's pretty cool. And lastly, I wanted to talk about kind of how we can do better. So these are, I guess, research areas. Data analytics it's new. AI specifically is incredibly new. We're still learning as we go. There's still a lot of ways in which we can improve. There's a lot we still don't know. And so the first how we can do better is scientific understanding of learning, especially deep learning algorithms. Deep learning algorithms are a specific group of algorithms that have to do with artificial intelligence. I didn't really talk about it here because it is just slightly complex. But what's happening now is that even though it's great and it's mind-boggling how it works and how, the model is understanding these relationships in our data. It's very great. It's great. It's awesome. But right now what's happening is that it's become like a black box. And so we have this model, we give it data, it learns some things, it figures out some stuff, and then it's able to predict, or it's able to, find those relationships. And all of that's great, but we don't really understand it. We don't understand it enough. And we're not able to say why the model does action A and not action B. It's like a black box right now. And so just learning that, and if we did learn that, we would be able to make it better. We would be able to fine tune some things. We can already do that, but there's lots of scope for improvement. Another area of research is, so right now you would have multiple data sources, and you usually need that because the more data, the better. But as we talked about earlier, it becomes kind of painful to go through it to actually get all these data sources. Sometimes there are privacy issues, and you don't have access to it. Sometimes this data that you want to use hasn't even been generated yet. And the best model can't handle all these data sources. You have to actually make them one before you can pass it through the model. So is there a better way to do that? That's a lot of a data analyst time just on that first step of getting all this data, combining it, making sure everything looks right before we can do anything with it. So can we make that better? And then inferring from noisy and or incomplete data. Right now, again, the machine learning model is not able to separate between noisy or incomplete data. If you give it data, it will try its best to make sense of it. And so what we have to do is early on, we have to clean that data. We have to make sure that when we pass it through the model, it makes sense. So is there a better way to do that? So that, again, your time isn't wasted on stuff like this. Trustworthy artificial intelligence. I don't know if you've seen any, but I've seen a couple movies where robots take over the world. And I mean, that is a real question to be asking. Are robots or AI robots going to take over the world? Are they going to, at some point, not now, we're very far away from that, but at some point, are they going to have the ability to make decisions and think on their own and possibly be smarter than us and possibly feel the need to govern us? How much do we trust them? Even now, there are many fields or many applications in which they are trusted to make life or death situations in self-driving cars. They're driving the cars, and if a person's on the road, they choose whether or not to hit the person or not. What if two people are on the road? Then what happens? How do we teach it to do that? How does that work? In lots, not just in healthcare, lots of different places, they make really important decisions that directly impact human lives. So how much do we trust them? How can we make that better? So that we do trust them more? And then you have computing system for data intensive applications. Right now, just building your model, training your model, and being able to accurately give out predictions, it can take anywhere from hours to days to weeks. I know for a lot of my projects, when I was building my models, I let it run overnight, or I let it run for 3 hours. I went and did something else because it takes a while. It's a lot of processing that it has to do. So how do we make that better? What's the next? Are we going to keep just staring at our laptops until the model does something for hours? Is there something we can do to make it better, and how? Automating front to end stages of the data lifecycle. Like I said in a couple of other points, There are lots of things that a data analyst has to do in the beginning before we actually get into the model building and like the actual core of data analytics. How can we make that better? How can we automate so that we don't have to do all these manual things to make our data cleaner for our model? And then we have privacy. I mean, privacy has always been an issue. The more data you have, the better. But also, you're getting data from people. Like, these are people's personal information, and so it's really hard to get that information. It's really hard to convince people to give you that information. And then also, when you do have that information, you have to make sure that it's secure, because this is important confidential information now. How do you make sure that it's secure so that it doesn't get in the hands of someone else that could do something else with it? And then finally, I have a slide just for ethics, because I think ethics is super important. I think that with this new environment that we're in, where there's data all the time, where people are using data analytics all the time, where we're constantly in touch with it, it raises a lot of ethical issues. So first, the ethics of data. How is this data generated? Do the people that it's generated from, do they know that they are the ones generating this data and that it's being recorded and that it's being shared with you? The ethics of algorithms. How does artificial intelligence or machine learning interpret that data? So in that picture there, this actually happened, I think, in Amazon while recruiting. They had a recruiting algorithm to help them. So whenever someone sent in a resume, this recruiting algorithm would go through it, and then it would say yes or no. And if it was a yes, then that person would go to like the higher level of the interview, and otherwise they would be discarded just like that. And what they found was that the recruiting algorithm had a bias to men. And so if a woman was to send in a resume, the algorithm would just say, nope. And that's because of the way it was taught. So when they went and said, this is a good applicant, this is a bad applicant, this is a good applicant, this is a bad applicant, there were more men in there than women. And so one of the features that it learned was, okay, if it is a man, it is a good applicant. And that's not fair to anyone. And so there's lots of inherent biases that we could be introducing into our models that we don't know about until it becomes a problem later on. So how do we make sure that doesn't happen? There is a list of practices, I think, something like, I don't remember a lot of them, but I know that if you were to go online and you were chatting with the chatbot, the company or the website would have to tell you, like, they can't pretend to be a person, but it's actually a chatbot. Like, there's lots of already existing rules and regulations, but there's also a couple of problems. There's a documentary called The Social Dilemma, where it's just talking about how, because of big data and data analytics and all these social networking websites, we as a people, as the world, we're more divided than ever, because Facebook is showing me content that's against someone else, and then I just keep seeing content like that, and then I build up this hatred towards a certain group or a certain minority of people. So ethics is a real problem. So how do we fix that? How do we make that better? Those are all the research areas. Those are all, how do we do the thing but do it better? And that's basically it. That's all I have. I hope you enjoyed it. I hope you learned a little bit. And I'd be happy to take any questions anyone has.
Now we'll move on to the question and answer session. So if there are any questions, you can raise them.
No questions. Everyone's learned all the things. They know all of it now. I did such a great job. No, I think we're good.
Are there any questions?
It doesn't look like
She's
it.
waiting.
No, it's fine. It's okay. You don't have to bombard me with questions. I'm good. Oh, I see something. Oh no. How do I see the chat in this thing? Sorry, Annie, are you able to,
Yes, ma'am.
can you just read out the question to me just
Okay.
because I can't find it? Oh, it's here. Okay, so someone said after a model runs through data, should you put it in more data to see if it's classified? Yeah, that's exactly right. So usually we separate our data into a training set and a test set. So your model, or you will put your model through the training set first so that it learns these relationships, it learns these features and things like that. And then to make sure that your model is doing what you expect it to, you would run the test set on it. And you would make sure that the model's predictions are in line with the actual values that you're looking for, just to make sure that your model classifies correctly. Yeah. Thank you for asking. No problem.
Hi, ma'am.
Hello.
My question is, can you mention a few problems that data analysts will encounter while programming the analysis?
Yeah, for sure. I think a lot of the problems come from the initial steps, where we are getting information, standardizing it, cleaning it, all of those things, because a lot of these models or a lot of these graphs and things, they're all built in to R or Python to make our lives easier. And because those steps every data analyst needs to do no matter what. You always need to visualize your data. You always need to use these modeling algorithms to do something with your data. But the first couple of steps differ from person to person, case to case. And so that's the step that's really annoying. That's the step that's really time consuming. And so again, like I said, if there was a research area that people are looking into actively, is there a way to make that better? Like, we know that this is a problem, we know that it's difficult. How do we make it better? How do we automate it? But yeah, I hope that kind of answered your question.
Okay, thank you, ma'am.
No problem.
Any more questions?
Hi, ma'am.
Hi.
Which is a better Python IDE for data visualization nowadays?
Sorry, what was the question?
Which is a better Python IDE for data visualization?
So there's lots of packages that you could use. I can't remember any off the top of my head. There's like NumPy, there's I can't remember any off the top of my head right now, but in Python specifically, I find that there is a lot of built-in packages and things that you could use. So you just put in your data and it gives you a nice graph. For R, there are the same type of things, but it's less Like Python's, it's very colorful. It's very easy to understand what's going on. R is more black and white. If you want to do additional things to it, it takes a little bit more effort. There are many Python packages that you could use. I just don't remember any for some reason off the top of my head.
It's okay, ma'am.
Any more?
Hello, ma'am. Hello,
Hi.
ma'am. Does Python is essential for artificial intelligence?
I'm so sorry, I didn't hear that.
Does Python is essential for artificial intelligence?
No. I mean, all of the stuff you can do in any of like the languages that have these built-in methods for artificial intelligence and for neural networks, for recursive neural networks and things like that. So it doesn't have to be Python. For artificial intelligence, I think I've used R2. So it could be anything. There are always built-in things that you could do. There's always resources online for help. There's always someone who's done it before you, who's asked these questions before you, so you could just go online. But no, it's not just Python. It could be anything.
Thank you, ma'am. Thank you.
Of course.
Answered. Thank you, ma'am, for giving your valuable insights on this topic. That was really a wonderful presentation. It was nothing short of incredibly informative and interesting. Presentation really transformed the meeting into a highly productive one. Once again, thank you, ma'am.
Thank you so much for having me.
Yes, ma'am. The participants shall fill the feedback form in the chat box for these certificates. Next, I welcome Sri Lakshmi KK of 3rd BCA to propose the vote of thanks.
Respected Chief Guest of the Day, Ms. Anmira Joseph, Principal, Dr. Sister Maggie Jose, our dear HOD, teachers, and my dear participants. I deem it's a great honor to propose the vote of thanks to all who have helped us in making this webinar such a resounding success. First of all, I would like to propose hearty vote of thanks to our dear Chief Guest, Ms. Anmira Joseph, for gracing today's webinar. Thank you, ma'am, for your very interesting and thought-provoking address. Next, I would like to express our gratitude to our principal, Dr. Sister Maggie Jose, for her presence in this webinar. I would also like to thank our beloved HOD, that's Miss, for her support and guidance. I am happy to express the vote of thanks to our dear teachers. My sincere thanks to all the dear participants who have turned up in such great numbers for joining us today and making this webinar such a grand success. Thank you so much for your cooperation. Once again, I thank all for your cordial cooperation. Thank you.
We have come to the end of the webinar. I would like to thank everyone who made this a grand success. Thank you.